Hello and welcome to SoftServe and AWS joint webinar on Containerization, the DevOps revolution. Let me introduce to you our speakers, Valentin Kopov, Solutions Architect at SoftServe, and Craig Williams, Solutions Architect at AWS. Guys, how are you today?
Hi, it is Valentin Kopov here, and I'm working as a Senior Solution Architect and working with the Big Data solutions in our company, working closely with AWS tools to provide our customers with very exciting projects. And today I will spot some light on what is the containerization in a nutshell and get back to some of the roots, how it appeared on the market and how it helped us a couple times to solve really complex and really interesting problems. And I will start from the question why containers are such a big deal and why they now probably number one trend in IT world, right? And the easiest way from my point of view to explain what container is to try to compare it with virtual machine, because virtual machine is like very traditional word and most of the people familiar with that, right? So if we will compare container with a VM, we can imagine it as a lightweight VM. Because it has its own process space. It can run commands as root. You can install some specific packages and even specific services from the container. And you can even get like a shell connection to this container, right? But the main difference is that virtual machine can have a different guest operational system, while in container you always have to use a host kernel, right? Which limits you to the number of different operational systems you can run at the same host. And from the host operational system perspective, the containers looks like a bunch of processes, while in the virtual machine you have this better abstraction, better isolation of processes from the host machine, right? And if you will take a look on this picture where we have a comparison between containers and VMs, you can see this, that in virtual machines we always have hypervisor which can host different guest operational systems on top of it, while in the containers we always have to share this host kernel, host operational system, which puts some limitations on one hand, but on the other hand, it gives sometimes better performance, sometimes it gives better flexibility and speed to deploy these containers. And I will talk about it in a few seconds. So just to get understanding what made it possible to create this great technology like in containers, we need to get back to the technology which was invented in the Linux world, which is called cgroups. Cgroups is a way to control how many resources, such as CPU, memory, or like block device input, output, and network, can we allocate to specific process or set of processes, right? For instance, we can say process A can consume X amount of memory, Y amount of CPU, and so on. This technology allows us to distribute this host operational system resources between different containers. And the other great technology in the Linux world is a namespace. Namespaces allows our containers to have different set of available resources. For instance, we can configure different containers to see different mount points, different processes, different even network resources, and so on. Which means that we have better isolation between containers. We can make two containers to not see each other, which is great, which is why we want to use containers. And one of the very interesting options of containers which differs it from the virtual machines is the speed of deploying container, right? Because when you deploy virtual machine, you need to spend some time on creating virtual machine image, which usually add disk I/O operation, which sometimes is expensive. But in the case of containers, because container is using host operational system, the great approach which is being used in containerization world is to instead of copying it one-to-one, it creates the snapshot of storage, and then it only tracks the changes which are made to the snapshot, right? So if you want the container to run exactly the same operational system, but only a couple of different configuration files, then you don't want and don't need to copy the whole host operational system. Just make a snapshot and keeps the difference between what has changed between your container and what was running on the host operational system. This, of course, helps to decrease the boot time, and it dramatically reduces the footprint, because, like, if you want to run 10 similar Linux, for instance, CentOS containers, you just use the same host operational system. You don't need to keep 10 copies of like CentOS operational system on the hard drives. And speaking about the main runtimes in the containerization world, the main of them are LXC, systemd, nspam, and so on. The most popular these days is, of course, Docker Engine. Everybody heard about Docker, obviously. But I would also say that this approach, containers approach, is quite old, and it was utilized previously in a FreeBSD, in jails, and in a very popular operational system called Solaris. It was called Zones, and it is not very popular these days, unfortunately, but previously it used to be very, very popular, and containers were implemented that days. And talking about the best solution for the containers, right? They all have one limitation. They all use the same kernel features, right? So the performance will be more or less the same, because you can't run faster than your host operational system. It's not possible. But what really matters is like amount of features you have and ecosystem. For instance, in a Docker Hub, you can see more than 100,000 different applications which are already configured. So if you need MySQL in a Docker container, you will find tons of different containers for Docker, right? If you want Cassandra, if you want Spark, it's already predefined, configured, and people already using it. So this means that you will get much bigger ecosystem if you will pick up Docker, for instance. The enterprise companies might also consider engines like container engines, which provide some certain level of support, of course. And now I want just to show you an example of how containerization is useful and how it helps to resolve real-world problems. And to answer this question, let me get back to the problems which we have at the moment in IT world. So the main problems is that previously we used to have separate clusters for different tools. For instance, we used to have Oracle database cluster, and then we used to have application servers clusters, which means that we had to use different virtual machines or real hardware for these clusters, and utilization is not spread very efficiently around them. And people start thinking about how to utilize these resources more efficiently. And instead of having different clusters like on this slide, people want to combine them together and run them as one cluster. And this way you can easily utilize it to 100% and make sure that you don't have spare resources which just wasted for nothing, right? And this being said, this means that we have certain requirements to these technologies which needs to be achieved in order to provide this. And of course, it is some kind of elasticity so that you can expand your cluster efficiently or decrease the size of cluster efficiently when you don't need the extra resources. And this is where AWS and Amazon does a great job, and this is something Craig will explain later in his part. So, so this example I want to show you is built on top of the AWS EC2 instances, and on top of these instances we built several virtual machines and gave control over these machines to the Mesos, which is another great technology which allows you to control big amount of Docker containers on top of virtual machines or bare metal, doesn't matter. And on top of these virtual machines, we've put many different big data services and tools and made them run as Docker containers, such as Kafka, Spark, HDFS, Cassandra, and so on and so on. So the idea is that, as I said before, is to maximize utilization of resources and share data between services. Because if you put, for instance, Cassandra database and Spark at the same host, this will mean that you don't need to send data over network between clusters. It's all inside one cluster, and data is being processed at the same place where it's being stored, which greatly increases the performance, right? And the way how the Mesos work in this case is it has a couple of master hosts and a couple of Mesos slave hosts where actual computation is being occurred. And the Mesos master is the host which controls the whole cluster, and of course you have a quorum of these master nodes in case if one of them fails. And then these Mesos masters decide where to put different Docker containers, and if some of the Docker containers fails, this Mesos master ensures that it's relocate failed container to a live node. So let's take a look on how does it work in closer. So Mesos provides a very good isolation of resources. This means that everything runs in container using C groups and namespaces, and each process doesn't see another process. So this means you can run like 10 Apache web servers on the same like physical or machine or virtual machine, right? At the same time, Mesos provides a great scalability because it allows you to see how resources are utilized and how many free CPU and memory you have and where you can put more containers if you want, right? And there is now actually a single point of failure because if one of the machine fails, it doesn't matter if it is slave or master, we always have spare machines. For instance, if Mesos slave process fails, master node can spot the situation and just relocate the containers which were running on this computation slave node to another slave node, and that's it. So this is a diagram of how the whole cluster is built. As you can see, it's all built on AWS EC2 instances, and then we run Terraform to provision virtual machines, and then we run Ansible scripts to provision Mesos and all our services. And this is the list of the containers we successfully ran in this cluster, and as you can see, these are the top big data tools and technologies on the market. And of course, there are still some issues, some minor caveats with Mesos and like Docker in general, and I just want you to know this like issues because it will allow you to better consider if this technology fits your needs or not. And of course, the first one is the service discovery, because if you run multiple containers on multiple virtual machines, you definitely need to know which resources run on which container, and you need to give your client applications an ability to clearly understand where the endpoints to connect to. And there are a couple of realizations of this service discovery. In Mesos, it is a console, and it works fine, but there are still minor issues, like you definitely need to define how to access your containers. And the other quite big problem is persistent storage, because in the Mesos, when one of the containers fails, it loses like the all data if it was stored in the container inside. So this means that you need to have some separate mount point or separate like shared cluster file system to keep important data, for instance, database files. And of course, Docker performance is sometimes smaller, not dramatically smaller, but a little bit smaller than just running some application in the host operational system. So these are like very few issues you might have with containers you need to know. And if you want more details about this particular example of how we utilize containers successfully, you can go to this website, which is mantle.io, for more details. And that's it from my side. And I'm glad to pass microphone to my colleague Craig, who will explain you what options and what tools do you have in Amazon to successfully and efficiently run containers.
Hey everybody, my name is Craig Williams. I'm a solutions architect with AWS and the SME for our container services and ECS. Today we're going to be covering ECS, which is our container service. We'll deep dive on exactly what ECS is, why you need it, and how it fits in with the container talk that you've just listened to. So running Docker containers is pretty easy, right? The Docker run command makes it super easy to spin up a couple servers, run your containers. But when you start to get large clusters of these Docker hosts, things become more difficult, right? And so you need a management layer that's actually going to allow you to build a cluster of host instances and then help you actually manage your containers across the entire cluster. And that is the ECS service that AWS provides. It is simply a management layer. So there's no extra cost for running ECS. ECS, at the most basic, just runs instances with our agents on top of it, and those agents then run up your containers. So we'll step through every single piece of it and what it does. For flexible scheduling, if you think about running a large cluster, you could be running 500 containers, 1,000 containers. Those might be running on top of 50 or 100 actual Docker instances. So you need a way to schedule which containers are running on various instances. And that's something ECS will help you do. It allows you to define how much capability every instance has in terms of CPU units. And so you can then say, every time I spin up a server, I have 1,024 CPU credits available to me, and every container that I'm running might be using 50. Or different containers may have different allocations, right? And so ECS will then schedule where a container can actually be run, and if it runs out of space, it'll actually wait for you to increase the size of your cluster. So ECS is handling all of this for you. If you have to replace an instance, ECS will restart your containers on a replaced instance for you. So this is where now ECS starts to help you at scale. So again, it's not possible for you to manually have to manage hundreds of instances or containers or thousands. So ECS is going to do a lot of that heavy lifting for you. Let's have a look at security next. Since this is just a management layer, ECS really falls in with all your regular security. So the instances that are running, these are running within your VPC. They conform to your usual server roles, your security, or your IAM security, right? All of that applies. The roles that these instances run as also applies. And so, everything is still, again, contained within your instance. So, if it's a private VPC, then everything remains private within that cluster. ECS is also extensible. So either using the CLI or the API, you can plug into ECS. You can see what's going on within your cluster. That'll help you with things like service discovery. So you can, and then you can also actually connect in things like Mesos and other container management products can actually work and piggyback on top of ECS. So you don't have to just rely on what ECS provides. And then, of course, because everything's running as a regular instance, your containers have access via the host role to all our other services, right? So it's completely integrated with everything that you're running inside of AWS. Right, so next we're going to look at each component of ECS. If you have logged into ECS before, you may have been a little lost. You can't actually launch an instance from within ECS itself. So let's have a look at how you actually get something in there. How do you create a cluster? So we'll start with our actual instances. So you can go into ECS and you can create an empty cluster. Perfectly fine to have empty clusters just waiting for an instance to be added. But that's kind of step one, right? You go in, create your cluster, and then we have an AMI available that will have Amazon Linux and our ECS agent installed for you. And our ECS agent just gets past the cluster name, and then when that instance comes online, you will see it then registered inside of your ECS container. And it's that simple, right? So our agent as well runs alongside the Docker daemon on the actual instance, and our agent is also fully open source. So you can make modifications to it. It allows you to make modifications so the agent can integrate better into your environment. And then it is publicly available on GitHub. So if you find, there's a bug or something not working correctly with our agent, we do take pull requests and encourage you to submit feedback through that system. You've already looked at Docker today, but ECS, Docker is what it runs, right? The containers need to be Docker containers. That's what we run. Whatever operating system you built your Docker container with is fully supported. The ECS Docker hosts themselves will be running Amazon Linux. But yeah, Docker is what we use. And then, when you're launching these containers on ECS as well, you can connect your Docker containers with Docker Hub and our container registry. Our container registry is a drop-in replacement for Docker Hub. So, either one, if you want your images stored within your VPC and your AWS environment, then you can use our registry. Otherwise, you can just use Docker Hub. So we looked at clusters a little bit earlier. Clusters are restricted to a region. Clusters are where you group your resource pool with instances, and this is where, again, you define the number of credits that you want available to your containers. Pretty simple concept, not too much else to say about a cluster. So tasks are a really important concept to understand. A task is a definition for ECS on how to run your containers and how containers are dependent on each other. So I may have a website container that's running, but it has a dependency, say, on a login container that goes with it. And so those will get defined within a task. And the task also has things like, where does my image come from? How much memory does it need? How many credits is it using up? So that the scheduler can actually ensure the instances are available and, you're utilizing your cluster correctly and not just wasting space. And it also allows you to ensure that if a container fails to start, that the entire task can then be shut down, right? So that you don't start a website and its dependent, login agent or database didn't come online. ECS will just shut everything down for you. Next, we've got services. If you've used ECS in the past, this is relatively new concept, and a service lets you decide how many tasks you want to run, but more critically, it maps to the load balancers. And so I may have a task that's running a website. Now I can define a service, and I can call the service, mycompany.com, whatever I want to call the service, and I tell the service, right, you're mapped to this incoming load balancer, and I then say I want a minimum of 10 copies of my website. So I want 10 containers running for the service, and I want all my traffic spread across those 10 containers. And so this is how you integrate a load balancer into ECS. Instead of having to do it manually, it's far more efficient, and it's better with load balancing and auto scaling as well. So if I come in here and I say, my website's taking too much load, I can add more instances to my cluster, and then I can just come into my service and say, let's go from 10 copies of my website up to 20. And the scheduler will then launch across the cluster and launch all those new containers. So let's have a look at what one of these definition files looks like. Really sort of straightforward JSON document. In this example, the image being MySQL. When you use a name like that, it is perfectly valid that it's going to go to Docker Hub and that it's going to pull the base MySQL installation for you. Right? We specify how many CPU units we want to use up, how much memory we need, and then we can pass in some environment variables. And just for this example, right, we're not mapping any ports, but when you're running a website such as this one, we'll take a look. Right, we put in WordPress and we're mapping our external port 80 to the internal port 80. So what does a workflow look like? if I'm a developer and I have a Docker image, I will push that to Docker Hub or our new container registry. I will create a task definition. I will then tell ECS I want to run that task, and then I'll go back to ECS and I'll say, describe what's happening in the cluster, describe my tasks, let me see what's running, let me see, if I ask for 5 containers to run, if only 3 executed, you need to know. And so that's what those operations do. Next big piece with containers, especially containers at scale, is service discovery. And what service discovery is if, imagine I've got hundreds of containers running and they're using dynamic ports, right? I don't necessarily know which ports and what services are being offered by every single container. They may all be websites, but obviously, we have limits on, one external facing port being on the same port number. And so Docker will allow us to use dynamic ports, and we now need to have a way to figure out, how do we find out what's running within our cluster? And as of today, you're going to need to use a service like Console or Weave. You could go to Route 53 and use DNS lookups for ECS, but something like a Console service will be far more efficient, right? And the way Console works is you have a Console server running within your cluster, and every container that runs as a Console client, and it registers itself with Console and tells Console, these are the ports that are launched with, and these are the services that I provide. And then any other running container in the cluster can now query the Console server and find out where's my database, what's the IP address, what ports do I need to talk on. And so it's a great service discovery tool. It provides a nice admin interface for you to be able to see exactly what's happening in your cluster, how many copies of various services are available, which ports are used. And then it offers global environment variables, which are extremely powerful. Because your container can be running everywhere, you can't just have environment variables on the host. And so something like Console, again, will allow you to have pre-shared keys or other bits of metadata that you need available to the entire cluster, and any container can then query Console and pull down that information. Next, we're going to look at one of the easiest ways to get started with ECS, and that is using Elastic Beanstalk. So Elastic Beanstalk, right, is our offering to make it really easy for us to manage the environment for you, help you get an application up and running. Beanstalk will take care of load balancers. You can run single instances if you want, but Beanstalk, it understands containers and ECS. And so if you have, say, a container that has a database, maybe it's running PHP and you're running WordPress, you can take that entire container, push it up to your hub, like Docker Hub, and you can go to Beanstalk and then just give Beanstalk a small amount of information. Looks very similar to the ECS task definition. And what Beanstalk will do is it'll actually create you an ECS cluster. It'll launch instances within the cluster. It'll deploy your application, give you an endpoint, map it all to the load balancer, and within a few minutes you have ECS up and running with your application ready to scale. And again, it makes it super easy to stand up one server, and then as you see more load coming in, you can just go into Beanstalk and say, give me 5 more servers, and ECS will then take it from there, add all the capacity that you need. So it's a really great way to get started with ECS. One thing to note with auto-scaling in ECS is that you can use traditional AWS auto-scaling groups to detect load on the cluster servers and add more capacity, but you still need to either manually or write a script that will actually go and tell ECS, I want more containers. So auto-scaling groups will add the capacity, but you need to tell ECS that you actually want, more containers to now be running. This is just a quick screenshot of an environment that was built using Beanstalk. You can see on here towards the top right that we're running the Docker option within Beanstalk. The configuration is Amazon Linux, and what we're going to look at is what was the cluster that Beanstalk actually built for us. So in this case, I asked for 15 containers to be running. Since they all use a fixed port, that required me to have 15 different instances. And so Beanstalk actually came along and created our cluster here, which is this AWS EB and that long name. It added all the instances for us. And then if we look at our tasks tab, it added all those containers, right? And I can see here then, see my cluster, see my instances, and I can see that I have all my containers running for me. So this is kind of, it's a good view into the cluster, but you know, long term, and especially with really large production clusters, you're going to need a tool or method to actually visually, you know, see what's going on with the entire cluster. And for that, you know, I'm really a fan of a product called Datadog, and you can find them at datadoghq.com. But what Datadog do is visually let me have a look at this cluster that I just launched. And so here I have a heat map or a honeycomb map that actually shows me, you know, every container that's actually running in this cluster, and it changes color based on the amount of load. And of course, you know, that's a configuration that you can change. But it's great in a production environment if you suddenly see a hotspot of containers, you can then dig down into the actual host and see, you know, is my host misconfigured? Do I have a problem with an EC2 instance? You know, maybe you don't have the right sizing on your EC2 instance. And so this is just a great tool to go and try out and use it to actually manage your environment. And then on my last slide here, I just have, you know, what happens with an EC2 when I have a scaling event. So in this case, I said, you know, I need more capacity, give me 10 more servers, and within about 30 seconds, you know, ECS and Beanstalk take over and add the capacity that I just requested. So that's ECS in a nutshell. If you need more information, take a look at our website. Again, it is a management layer. You can use our free service tier to actually try it out. So if you're launching your nanos, your micros, you know, you get your 750 free hours every month. We welcome you to come along and sign up if you haven't, and then, you know, use something like Beanstalk to stand up some free services and give it a try. All right, thank you.